Okay, so today we're going to be modeling with nonlinear regression, so you need to make sure you have your calculators handy. Basically, what we're going to do is we're going to go through each of these problems, and you'll be using the graphing calculator to solve those. So this first is example 1 taken from your book. It says Mesa, Arizona is one of the fastest growing cities in the United States. Use exponential regression. So that's like your key word. Exponential regression is what we're going to be using right now to model the Mesa population data. Use your model to estimate the population of Mesa in 2020. And so what we're going to do is we're going to go ahead and enter this in a table. And so we're going to start with this at 0. We're going to start at years since 1900, 10, 20, 30, 40. And so where you're going to enter these in is you're going to enter these in where I have stated that. So we're going to go to Stat. Stat is located right by the left arrow on your calculator. You're going to go to Edit. Now, in L1, does everybody have an L1?
Yep.
No? Okay.
Oh, okay.
Okay. Just a second. Those of you that have L1, I want you to go ahead and enter in 0, 10, 20. Okay. And keep going. In L2, I want you to I want you to go ahead and enter in the population.
Do you have to keep going up?
Or is it
No,
go down?
go down.
0, 10.
Oh, you go down.
I
go
said
down?
L1 is the year. If you hit enter, it'll move down.
So put them all in there?
So
and just-
0, 10, 20, 30, 40, 50, 60.
How do I clear L4 then?
In L2, you want the population?
Yep, L2, I want the population. Okay, so in L1, you're going to put the year, and then once you get that done, you're going to put the population in L2. Now, one of the things you need to make sure of when you do this is that all of your numbers line up correctly. The other thing you need to make sure of is that you don't have any extra values in each of the columns. Okay, so once you get those entered in, what you're going to do is you're going to hit the Stat button and you're going to go to Calc. Okay, so once you've entered those in, hit Stat, go to Calc, and we're looking for the EXPREG. So go ahead and scroll down to the EXPREG button, hit Enter. Now when you hit Enter, you're going to get something that looks like this. It's going to say y equals A times B caret X. And then it's going to give you two values, A and B.
Then we hit enter,
Yeah, and then
Go down
what
to
you're going to do is just use your
calculate.
down arrow to hit Calculate.
enter.
Okay, because you want to calculate that.
What do you have to do? Because that Microsoft doesn't stutter.
Yeah.
So what do you get A to equal to 4 decimal places? 0.6901. What do you get B to equal to 4 decimal places? 1.0671. So what that means is we're going to plug those into our equation. So our new equation will be y equals 0.6901, since that's what A is, times 1.0671 to the x power. Okay? And so the question was, use your model to estimate the population of Mesa in 2020. So 2020 would be what value of x?
200.
120.
120, because we started, remember, 1920 was 0. So 2020 would be 120. So what you're going to do on your calculators, you're going to do 1.0671 to the 20th power. You're going to get an answer, and you're going to take that times 0.6901. And when you do that, what did you get y to equal? What?
1,673. I did.
At 2.5.
Oh, maybe it was 2.5.
1,673.
I got 1,675.
You to the power?
Yeah,
let's see what that means. This is the population in thousands. So in thousands, this would actually be 1.63 or 673 million people. So the population in 2020 of Mesa, Arizona, they're gonna predict it's gonna be about 1.673 million people.
That's
So if you look at where it started and where it's going right now, it's growing, big
Yeah,
time.
Well, till the foreclosures happen
Yeah.
and stuff. The economy dies.
So let's go ahead and look at another one, okay? Let's go ahead and look at another one. This is another example taken from your book. The internet experienced rapid growth in the 1990s, big time. The table shows the number of users in millions for each year during the decade. Use exponential regression, okay? And that's key. That's what you're going to look at in every problem because we're going to change. It's not always going to be exponential regression to model the data. Then use your model to predict the number of users in 2008. Let X be the number of years after 1990. Okay? So what I'm going to use for X here is I'm going to start with 1, and then I'm going to gradually go up. So now real quick, I'm going to show you a quick way that you can zero out all the values in your table. So if you go to Stat and you go to Edit, go to where your L1 and L2 are. Use your arrow keys to highlight L1. So move your arrows along so that L1 is the only thing highlighted, okay, at the very top. Okay, hit the clear button, which is located right by the down arrow, and then hit Enter. Now that gets rid of absolutely everything in L1. Do the same thing with L2. Use your up arrow and your right arrow key. Highlight L2, clear, enter, they're all gone. Go ahead and start entering those values in. Enter the year in L1 and the internet users in L2.
I don't have an L1.
How did you do the last one?
Is that 8-6 or 6-6?
8-6. If you're trying to follow along, these are also taken from the book, so these tables are also in the book. So if you're having a hard time seeing the board, in section 3.5 of your book, they should go ahead and be in there. Okay, once you get those entered in, remember once again, we're gonna go back to Stat. Where are we gonna go then? We're gonna go to Stat, Calc, which one? EXPREG. Okay. Okay, so what did we get for our equation? Y equals? Yep, I know. It'll be the same thing as before. 0.4432 times 1.6962 to the x power. Okay, so now that is our first answer. That is our exponential regression model. Our second answer says use the model to predict the number of users in 2008. So what number am I going to use for 2008? 18. So go ahead and plug in 18 for x, and that will be our second answer. So we've got 1.6962 to the 18th power. We're going to take that times 0.4432, and when we do that, what do we get? 5,986.69. And so what ends up happening is, since this is in millions, our answer actually is going to be 5.98, I could probably go 987 billion users.
I don't get this whole billion. Isn't it millions?
It was millions at 5,000, right? Didn't it say thousand or millions?
Yeah.
Users in millions. So if it's 5,000 million, okay, that's the same thing as 5.9 billion. Okay, because this is going to be million, so if I move it back here, that is a billion. So 5.987 billion users. All right,
Little internet.
This one is logarithmic regression, so let's look at this one. Use logarithmic regression, big difference now, to model the data in the table about twin births in the United States. Then use your model to predict when the number of twin births will reach 150,000. Just a little tidbit, if you're using logarithmic regression, you can never start at 0. Okay, so we're going to do the years since 1990. So this one would be 5, 7, 8, 10, 12, 14, and 15. So go ahead and enter those values in L1 and L2. Now this one is different. Since we're doing logarithmic regression, when you go to calculate, if you scroll down, which of those do you think will be the logarithmic regression one?
LN.
LNRAG. Okay, so LNRAG. So this is what you're looking for. LNREG. Now when you go ahead and run that and calculate that, you're going to get your equation. Your equation is going to be y equals a plus b ln of x. And so in this problem, they give us a to equal what?
38428.
Yep, 38,428.96. And they give us b to equal 35,000.17. So our equation is going to be a little bit weird. Our regression model will be 38,428.96. And you know what? Let's just, for sake of ease, let's just round that up to 38,429 plus 35,000 ln of x. So that's our first answer. Now our second answer, let's look at what they ask us. They say use your model to predict when the number of twin births will reach 150,000. So what does the 150,000 equal?
X.
This is x, or L1. What is this? Y. So where's the 150,000? With y. And so what I need to do now is I need to go ahead and solve this equation for x. So I'm going to have to use the tools that I've learned throughout the chapter in order to solve this. So what's the first thing you're going to do? Subtract, subtract the 38,429. So when you do that, what does that leave you with?
11,000, no, 111,000.
111,571. What do you do now to solve for x? Divide. You're going to divide by 35,000. And so when you divide that by 35,000, you're going to get 3.19 equals ln of x, correct? How do you undo the ln of x? E. So I'm going to do e on both sides. And when I do that e, I get e to the 3.19. And what does that come out to be? 24.29. And so let's go ahead and look at what that means. It says use your model to predict when. So what will this be? 24.29 what? Years. And so let's put that into context in our problem. When would 24 years occur? 2014. For those of you wondering, it was the year since 1990, right? That was where we started right here. So I'm going to go ahead and add my 24.29. So when I do that, I get 2014. So in the middle of 2014 would be when the number of twin births would reach 150,000. All right. Ew. Okay, let's go ahead and look at this one. The table shows the average U.S. life expectancies according to birth year. Use logarithmic regression to model the data. Then use the function to predict life expectancy of a person born in 2020. Let x be the number of years after 1900. So what am I going to start with here? 50, 60, 70. Go ahead, put them in.
Oh, 95.
the end.
Oh, correct, right?
Now be careful, because this one doesn't always go up by tens. Okay? So what do we get our model to be? 15.09 plus 13.38 ln of x. So that is our first answer. Okay, our next answer says, use the function to predict the life expectancy of a person born in 2020. So 2020 would be x equals what? 120. So you're going to go ahead and do x equals 120. Let's calculate that. 15.09 plus 13.38 ln of 120. What does that come out to be? 79.15. So life expectancy, 79 years. Questions? Fairly straightforward. The last thing we're going to talk about is something known as logistic growth. Okay, basically from logistic growth, this is what I need you to do. I need you to understand what this stuff is. Okay, the logistic growth function has the form. That's not real important because you can go ahead and get that form from your calculator. What you need to understand is that with the logistic growth function, there are two bounds. There's a lower bound, which is y equals 0, and there's an upper bound, which is y equals c. And with that logistic growth function, it will never exceed that upper bound since it's an asymptote. Okay, it's going to get pretty darn close, but it will never actually cross that. And so what we do is we call that the carrying capacity of the function. And that's the limit to growth c. And so that means we will never, ever, ever exceed that top value. So that is called the carrying capacity of the function, and it's the limit to growth as well. So what we're going to do in the next example is we're going to go ahead and look at how you create a logistic growth function. We're going to do that. And we're going to find out, in fact, what is the top limit, what is the limiting limit to growth in that problem. Okay? And once again, this is another example taken from your book. Okay, use the keyword here, logistic regression. Okay, so up until then we've done exponential, we've done logarithmic, now we're going to use logistic. And we're going to go ahead and enter in our values here. In L1, you're going to enter in your years, which are actually the time. I take that back, time in hours. So you're going to go ahead and enter all the way to 18. When you get that done, if you want to hold on, I can read those values to you, and you can type them in as I read them, if you would like, instead of having to look up 18 times. Okay, if you want to look, that's fine too. Okay?
Yeah.
Number 1, if you want to go down, it should be 10, 19, 31, 45, 68. Number 6, we should be at 120. Okay? 172, 255, 353, 445, 512, 561. We should be ready for number 13. 597, 629, 641, 653, 654, and 658 should be the very last one. Okay, so you should have 18 values. Now, I need you to go ahead and go into the calc menu. 18, sorry.
What was 8 though?
8 was 255.
This one just
So if
be
you go into the
logistic.
calc, which one do we go? Logistic. Okay, so we're looking for the logistic one right here. Okay, letter B. if you calculate this, I'm gonna warn you, it's gonna take a while. You're gonna think that your calculator's freezing up. You're gonna notice there's a line moving on the upper right. It is thinking, and this one does, like I say, take a while. Okay? So we're just gonna wait for things to pop up. If it's still going, that's fine, mine's still going as well. Okay? But it'll take a while because this logistic one does have a lot of calculations that get involved. And so here is what our original equation, and mine actually just popped up right now. So 1 plus AE to the negative BX. Everybody get something to pop up? We're going to go ahead and fill in what we got for each of these. What did you get for A? 131.18. Very good. What did you get for B? 0.55. Yep. What did you get for C? 661.56. So it says to plug that into a model. So our model is going to be 661.56 divided by 1 plus 131.18 e to the negative 0.55x. Okay, that is our model. Now what it asks us to do is it says use your model to predict the limit to the growth of the yeast in the culture. So what is the limit to growth in this problem?
658.
6 what?
58. I was just looking at the last number.
What is the limit to growth?
664.
Why do you say that?
Because it says limit you see.
Yep, you're right. Okay, if you didn't catch what Brooke was saying, okay, the limit to growth is what C is. That is your top value. It will not go above that. So in this case, it's not going to go above 661.56. Or what we could do is we could just round to 661. So that is our limit. We could actually, I think I put 661.56 in the problem before. That is our limit to growth in this problem. Okay, it's whatever the value C is. Questions? All right, you have some problems for me for tomorrow. Okay, these are due tomorrow. Remember, your test is Thursday and Friday of this week. So page 207, 2 through 14, the events.